question, but I'm like, wait, hold on here. And that's 100%.
Where is it?
We're on our own, Dan.
Okay.
Yeah. On your own today, in terms of notes, 2 things that I would love to accomplish today. Thing number 1, 4 examples. Boom, 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 and boom. Yeah. Okay? 4 examples today. And then I have a worksheet to hand out for you too. Okay? So far, up to and including this very moment right here, you should have 2 worksheets. Okay? You should have a graphing exponential function worksheet on the salmon, and you should have a application type worksheet also on the salmon. You should have those 2. Today you're going to get a 3rd one. It will be a solving equations type of worksheet. Tomorrow you'll get the chapter review worksheet in preparation for 1 week from today, 10/10, of having a chapter 3 exponentials, logarithmic, logistic test. Okay? Good times. Let's hammer out this first one. Let's do this first one together, and then the next couple I'll have you do on your own. So 4 times 3 to the x divided by 2 power is equal to 108. Okay? So the very first thing is we need to isolate, I almost said identify, we need to isolate our exponented or our logarithmic term. So that is our exponented term. We need to isolate that. So the very first thing that I am going to do is I'm going to divide both sides by 4. When I do that, on the left side, I get 3 to the x over 2 power. And that then is going to equal 27? Yes. 27. Okay. Now, I have 2 options. Okay. One of the options happens some of the time. The other option happens all of the time. Okay. The sum of the time option is I could write this as 3 to the x over 2 power equals 3 to the 3rd, because 27 is 3 to the 3rd power. I can do that, and then I could say from that, I could say that x over 2 has to be equal to 3. The exponents have to be equal because it's an equality statement, and therefore x has to be 6. I could say that. That's legal to do in this case. Not always going to happen, because if this number here was not a power of 3, then I can't do it that way. It just so happened that I could write 27 as a base of 3 with an exponent. Okay? Sometimes a broken clock is right twice a day. Okay? In that cases where it doesn't work, then we have to switch forms with it. So then we would say that log base 3 of 27 is equal to x over 2. In this case, if we used change of base formula, if we didn't realize that 3 is the exponent that I put on 3 to get 27, okay, we could do change of base formula, and we could figure out log base 3 of 27, log of 27 divided by log of 3, natural log of 27 divided by natural log of 3. Either way, we get 3 there. And then that takes us to the same spot we were at for x being 6. Questions, comments, concerns, clarifications, haikus. Look, what is it? 573 or something like that in the haiku? No, 575. Two of the three numbers. I hated writing haikus back when I was your age. Hated it. All right. Oh, snap-a-lappa. So you be the picker. I'll be the grinner. Together or by yourself? Together? Okay. What's the problem with this one? It's a lot of what? It's a lot of logs, right? Right? We got a lot of logs. Okay? So we got to do something to get it down to where we don't have as many logs. Is there anything that we can do to get it down to where we don't have as many logs? What am I going to multiply? Do you remember what rule, what property we called that one? It starts with a P. It's another word for multiplication. Product property. Yeah. We can apply the product property here on the left side. So we can make this be the natural log of the quantity x minus 3 times the quantity x plus 4. Love it. Is there anything else that I can do? Any other property that I could apply? Notice how I haven't finished off the equation yet. Guess what? What do you got? We can apply the power property, the other P property. Okay? So this could be the natural log of 2 cubed then. Oh, I like that. Now, we got natural log of something equals natural log of something. So what's got to be true? If we've got natural log of something equals natural log of something, what can you tell me? What? The somethings have to be equal, right? So let's get rid of the natural logs and let's just write the somethings. Using your algebra skills, solve that for me. Go. Agree with me on solving that. Final answer is I don't know if I can squeeze it up. I'm going to move up. Let's see if I can slide this up a little bit. Now I can get it all in one. Final answer is oops. Why is my final answer just 4? What can't be a negative? It's an A word. Or I'd even take a B word too. The argument can't be negative after I plug it in. The other one is the base can't be negative when I plug it in. Okay? Alright? So if I plug in -5 into the very first one in my original equation, I get the natural log of -8. And that just can't happen. I can't take e to any power and get a negative number. Okay? So -5 gets thrown out. It's called an extraneous solution. When I plug in 4, I get the natural log of 1 plus the natural log of 8, which is the natural log of 8, and the natural log of 8 is the natural log of 8. Okay? So it works out. Okay? Gotta check our work. Love it. Oh, snap-a-lappa. We want to solve this for x. Oh, snap. Want to know a quick and easy math trick to help solve this one? Nope. We'll have to go to a calculator in this one, yes. But even before that, quick and easy math trick. These two, this and this, can be flip-flopped. Okay? Because if you think about it, to get rid of the fraction, I'm going to multiply by that bad denominator, right? Then I would have to divide by 200. Okay? So in the end, I'm going to get 500 over 200 equals 1 plus 25e 0.3x. You can move stuff around on the diagonals in a ratio. Okay? 500 over 200, what's that reduce to? 5 over 2, right? Okay, what will we do next then? I'd subtract 1, yeah. 5 over 2 minus 1 is just going to be 3 over 2. Now what? What we got next? Got to isolate my exponential term. So what's next? Divide by 25? Dividing by 25 is the same as what? Multiplying by 1 over 25. So that's then going to give me 3 over 50 equals e to the 0.3x. Now what? What? Switch forms with it. Okay. Log base e. How do I write log base e? Natural log. Natural log of what? What? Wouldn't it be 3 over 50? Okay. That one. Equals 0.3x. I'm going to need a calculator on this one now. This one too. Both calculators that I grabbed are warming up. Alright? So we want the natural log of 3 divided by 50. That's going to give me that. And then what do we got to do with that? Divided by what? By 0.3? I get -9. Typically, we'll round to 3 decimal places. I think on the test on Tuesday, I have you, when we're rounding to 3 decimal places. So I would say here, -9.378. Okay. You try that one. Log of thirds 27/8 is going to be here, -3. Bless you. I get 0. Yeah? And if you check it, 2 times 0 is 0. Minus 3 is -3. 2/3 to the -3 power is 27/8. Times 8 is 27. Minus 10 is 17. Checks out. Ooh. Nailed it. Okay. So I've got a solving sheet then to work on for the second half of class. This one will be due on a week from today, on Tuesday the 10th.